right? Some directive is over there, so it will change the color of background. So now you can see this thing, right? So from here it is loading this. So over here if I change the name, add my name, it will change the name, I can change the URL. So something like that, I don't have to create a ng module for those particular things. Only thing which is changes this bootstrapping of application. So we have to change it a bit. Other than that, this one is there, standalone true, that's all. And your component will be independent of any sort of module or any sort of things. It will be like, it will help you a lot while you will create a big application and you want to pull out that particular component from the things. So it would be very easier for you. So this was all about, previously we talked about the type angular form. So it is type checking for the form value. Optional and required control are enforced over there. So it was previously also there, right? And the form groups are aware of their child control. So yeah, so right now we will get the suggestion as I was telling you. Other than that, recommendation to use type form is a new forms, right? They will always give you like suggestion over there about what we can use and all. Other than that, related to standalone components, so we already talked about this. So basically, whenever you have to create a new component, you just have to go inside your terminal and say ngc, like this one, and then you will say like with the flag of standalone, and it will create a standalone component for you in your application. So make sure your application is updated with the Angular 14, and then you can avail this sort of things over there in your application. And yeah, basically this will help you a lot while you are lazy loading your components. So you can add over there in your routes, and you don't have to do a lot of efforts to divide the components and all. You just have to create a component and not have to divide every module, each and every module. You just have to add that component over there in a route and you are all done. Right? Yeah, so these are few sources which I took help from. So maybe if you want to go through that, I will be sharing my slides. So maybe you can check that. You can connect with me on LinkedIn or Twitter or any other way if you want if you have any question or if you have anything to ask with me, you can just connect with me over there and we can discuss it. Yeah, that's all from my end.
Thank you. How many times have you had customers coming back and asking us we need the lazy load? And today, it makes our life much easier. So anyone got any questions for Srishti? Anybody here? I guess no. So that was a great session. Thank you so much for your time. And that was really insightful. So as Srishti said, so you guys can connect with her on the LinkedIn. She's with the same name, Srishti Jain. Thank you, Srishti. Thanks for your time.
Thank you so much. Thank you.
Thanks. So now for our next speaker, Mr. Pranab Jyoti Bardalai. A big round of applause, please. So he is going to talk about GCP, MVP, microservices and more. He is the Director of Engineering at Jungle Games and he's worked with a lot of multinational companies like TCS, Walmart, etc. So he's going to talk more about what exactly is GCP, MVP and how we can use a GCP now, microservices and MVP. Welcome, Pranab Jyoti. Over to you.
Thank you so much, Ashfiza. First thing first, what you can expect from me today is a lot of fumbling, nervousness, and if you can get through those barriers, little bit of GCP, MVP, and microservices, how we connect these three worlds. Three worlds because MVP, that's the minimum viable product, which is a business space. Microservices, which is one of the latest and greatest application architecture patterns, which is technology in the solution space. And we have GCP, which is one of the greatest infrastructure solutions we have in the world today. So how do we connect all these three pieces? I'll try to take the first principles approach, see how the basics of these three connect, and then help us stitch them together. To start, can we get the first slide, please? Well, I work for Zangli Games. We have our offices in Bangalore and Gurgaon, and I work as a director of engineering. We are always hiring, so if anyone is interested. Okay, to get started, what is an MVP, a minimum viable product? This is the best approach that we have seen working behind every successful product that has gone live in the recent past. Particularly important because if anyone here is interested in the entrepreneurship startup world, very important for startups to get to test our ideas before we get go too far ahead and then realize that we should have taken the right turn where we took the left turn and we need to course correct. MVP is the approach to do that. This is a collection of the core features, the minimum requirements that we need to fulfill, or the minimum set of hypotheses that we want to test. Before we talk about MVP, the Maslow's hierarchy of needs, this is an idea in psychology, not a law, as we famously see other laws in psychology which have been proven by some scientific experimentation. Maslow's hierarchy has not been proven. Hence, it is only an idea in psychology, which states that only when some of our base level needs are fulfilled, we demand more for the next level of needs. For example, if we have food and shelter security, we will think about family, friendship, respect, achievements, etc. Next slide, please. Dan Olson, famous product designer, he derived Olson's law of web user needs, Olson's hierarchy, not a law again. Sorry about that. Speakers get irritated when attendees get phone. Now imagine how irritated the speaker will get when he gets a phone. So Dan Olson derived Olson's hierarchy of web user needs, and we can use the terms web user needs and app users interchangeably here. Today is more about applications, not so much about web. But what it states is that as a user, we first care about, is the service up and running? When I hit a certain website or maybe an application, is it up and running? Is it responding fast enough? Does it work? I mean, at least it can get the basic things done. Does it have the basic set of features that can help me fulfill a certain task? Uber, Ola can help me get a taxi book, etc. And then if all these things are working, then we care about, is the service easy to use? Now, this is the business space, the problem space. When we relate these concepts to the technology, the solution space, is the service up and running? It translates to the uptime of our services in technical terms. Is the solution fast enough? Relates to what is our page load time, be it a mobile application or a web application. Is the client responding fast enough? Does it work? Relates to, are there too many bugs, or can we just get through? The user can comfortably get through the journey. Does it help me fulfill my task? It relates to what are our feature sets? Ola, yes, it helps us get the taxi book, but then it has certain other features, payments, etc. And then last of all, like once I have all these, then I, as a user, I start caring about how easy it is to use a certain application or a service or a website. That translates to user experience design. Ifika will know more about that than me. So this is the Olson's hierarchy of web user needs. Now when we look at it, Maslow's hierarchy of needs and Olson's hierarchy of web user needs, we tend to think that what is an MVP is a collection of the core functionalities. Of course, that is true, but is that enough? Next slide, please. This is what we think when we think about an MVP, is that it has a set of functional features, and we do not worry too much about reliability, usability, and delightfulness of the solution. That's the traditional definition. There is a different school of thought where we think that this is not a right definition of MVP. Next slide, please. The right definition should be, yes, the core features or majority of the core features that we want to get the tests done for or get the user feedback on. Little bit of reliability, maybe not as much as functionality, but some bit of reliability, some bit of usability, and a little bit of delightfulness as well. Why so? Again, taking the Ola example. It has, for example, hypothetically, it has all the features where we can book everything, all the services are working fine, the core flow is totally perfect. But at the final step, we cannot find the book button. Will it work? No. That's where user experience comes into picture. So little bit of everything is very important. So it's not the horizontal slice of the pyramid, what is MVP. A true MVP is actually a vertical slice which cuts across all the layers. That's where we can test the real customer feedback. If the user, in the hypothetical example of Ola, if the user cannot find the book button and book the cab, we are never going to find out whether the users are really looking for a solution which will help them find a cab. So that's the true definition of MVP is what? The new definition of MVP rather in the industry. Next slide, please. Now, this definition was in the problem space, the business world. Now, when it comes to technology, the solution space, the equivalent, if we have to support an MVP, we have to think likewise. And for that, we have a minimum viable architecture, or we also call it the evolving architecture. Why evolving architecture is very important is, if in the business space we are thinking from a minimalist standpoint that we want to implement only the core features, and at the same time as technologists, we usually tend to build something very concrete. We tend to, if someone asks me to design a service, intuitively I'll try and design it for 1 million users, not the first 100 users. Am I really targeting 1 million users on day one during an MVP? Highly unlikely. I probably am targeting only 10 or 100 or maybe 1,000 users on day one or the first month. That's where a minimum viable architecture is very important. It aligns well with the product thinking. Speed, of course, if I try to build a fully mature solution, it will take much time. If I try to build rather only what is required, it will probably need, definitely need much less time. And premature optimization of a technology solution, yeah, we have seen solid technologies which have failed. We have seen crude solutions which has evolved step by step, and they have been leaders in the market. Next slide, please. So, now we talk about MVA, the minimum viable architecture, and when we talk about application architecture, microservices is one of the most known patterns that we use. Now, when we are defining any application or maybe a minimum viable architecture, do we need to use microservices is the question that we face very often. It's not only about startups. In startups, this question is more prominent, but even today, even in established organizations, whenever we are trying to build something from scratch, this question always comes to mind. Shall we build the microservices way? There is no right or wrong answer in technology. This I have come to realize after spending a few years in the industry. Any problem that we have got, any business problem we have, will have multiple options in the technology space to implement the solution. each of these options will have its own pros and cons. The trick is about, as an application architect, to pick the one which suits our use case the most at that point in time, given the facts in hand. So the best technology architecture is actually a myth. What we rather have is the least worst architecture, least worst solution. So if we have to think of the least worst solution, microservices sometimes may be the way forward, may not be as well. Anybody here in the room who is familiar with the microservices? I assume a lot of people may have the familiarity already. Microservices, we very often talk about performance in microservices. You may know it, you may be familiar with it, that when we think about a performance solution, we think about microservices architecture. But there is also a myth here. Let's imagine a solution. We have a service, cab booking service for example, and we have it hosted on a server, say GCP Cloud Compute, it's hosted there. If I am the only user, or we have a set of users, say 100 users, and they are the only users who are going to use this service, and if we build the same solution in a monolithic architecture, which is another architecture pattern, and an application which is built on microservices pattern, which one do we think will be more performant? Let's consider this. One, say solution A, it takes 100 milliseconds. Solution B, it takes 118 milliseconds. Hypothetical numbers. Will it be the monolith which will take 100 milliseconds, or the microservices which will take 100 milliseconds, given we have only 100 users who are going to use this solution? Any guesses? Sorry? Microservices. Fair guess? If we have only 100 users, or only a user using a solution which has the same logic and all the other parameters are same, if we implement it the microservices way, it will have say 2 or 3, at least 2 services, or maybe 5 services. All these services will have to talk to each other. Microservices being distributed, they will be hosted on different machines or different pods in a Kubernetes environment. So they will have to interact with each other via the network. There will be some latency in the network calls. If on the other hand we build it the monolith way, nothing has to go out of the machine. So performance for 100 users, again I'm repeating the fact that we are considering only 100 users for this service. For 100 users, for the same requirements, the monolith will be much faster than the microservices. So that's where the answer is. If I'm building something new today, do I need to scale it for 1 million users, or do I need only for 100 users just to prove my hypothesis? There is the answer. Now again, as I said, there is no right or wrong, yes or no answer in technology. What if we do need microservices? What do we do then? We first separate the context. Payment, for example, is absolutely a different business context than inventory management. So we separate them out. And when we talk about microservices, there are certain parameters which will make us believe that the granular they are, it is better. There are certain other set of parameters which will tell us that the coarser they are, the better. So it's always about the balance. And that's how the IC software world is, isn't it? So, for example, security. The payment set of payment services will have totally different use cases and compliance requirements than the inventory management system. So the more separated, the distant they are, the better for us. On the other hand, the inventory management system and the order management system, they may have close dependency on the data, because if we have an inventory coming into our system, that we can immediately make it available to our users. If a user books a certain cab or certain maybe buys something from our solution, from our product, then we have to update the inventory immediately. So if we look at these data dependencies, then it looks like the coarser they are, the better for us. Again, about balancing. this brings us to the end of it. Like, we talked about MVP, we talked about MBA, evolving architecture, we talked about whether microservices is or isn't required, where we do not have an answer to yet, because it depends upon the use case and the parameters we have in hand. How does cloud, GCP, Google Cloud Platform, help us in these situations? Before the cloud came to being, we used to have private data centers. Yes, of course, everything started as a startup back then as well, but it was very difficult to get started with a startup back then because we needed to have a server where things will be up and running, we needed a physical space and all these things. With GCP now, we can just, I think it takes less than 2 minutes to create an account and then to book Google Compute Engine to host our solution there, and then we can just open up the connections and test our solution there. That's the minimum viable approach. And then as our solution matures, as our product, as our hypotheses are proved, we make our course corrections, we add features, we may need to scale this thing out. So what do? We bring in the Kubernetes, the Google ZKE. So these, actually I picked it from the GCP website, so those are the taglines for each of these products. But the idea here is that we can evolve our architecture on the cloud much easier, which is much easier than doing it on a physical data center for us, because we do not need to worry about procuring the hardware, keeping things ready, and all these things. That's of course a factor. And second thing is the variety of solutions that we have available on the cloud. For example, on day one, if we have our cab booking system, we may not need to worry too much about caching. Caching is the way of making things faster by making the data available in the memory rather than on the hard disk. So we go ahead with the bare minimum approach of storing the data on the database and then implement our solution. Then our solution becomes successful, and then we need to implement caching. We can bring it in as a plug-and-play architecture. That's where evolving architecture comes in. And that's when, as a product, we make our move from the MVP stage to a more mature stage. Our architecture moves on from an MDA to a more evolved architecture. Maybe we started with a monolith. Now is the time to take it to microservices, because we need to scale our solution from 100 to 1 million users. And with all these things comes the power of cloud, where we do not have to worry about infrastructure, we do not have to worry about availability, all things are granted there. Just go and implement and make our apps and products successful. That's about it. Thank you so much.
Thank you so much. It was really exciting. Before I would like to ask audiences any questions.
I have a question. Okay. I'm not used to speaking, so find out your place. Now, do you still do performance testing?
Oh, yeah. Performance test, this is absolutely very important. And it's irrespective of what, I'll come to you. It's irrespective of which architecture pattern we are using, performance testing is integral part of any lifecycle.
What is the tool you are using?
That will depend upon, like, we may have some in-house frameworks, we may have some, we have some tools there as well. Yes. Given that it's ZDZ, we will restrict to the Google tools, toolsets only today. But some of the examples, for example, when we are hosted on a VM versus when we take our solution to, say, ZKE, the Kubernetes solution, we know for sure that the ZKE environment has been load tested thoroughly by Google already, so we can bank on it. What we need to do is, the Kubernetes pod takes maybe few milliseconds or microseconds to come up, but the load time of an application depends upon, after the pod is available, how long does our application take to boot up? That's the performance test we need to do, and we may need some custom tools based on our applications. Yes?
So what are your thoughts between serverless microservices and between managed microservice, like you deploy in ZK or you deploy in a VM for an MVP?
I have a tried and tested answer. It depends. It depends upon the use case, but and that is true. It depends upon the use case, but there are a few things though. serverless or like Google Cloud Functions and all, it is very useful when we know for sure that our application is absolutely stateless. Anyway, when we are talking about microservices, it's kind of taken for granted that we are talking about a stateless application. If it is stateful, then yeah, we may also argue that it's not microservice or it's it's rather a monolith. Or at least it's not a cloud-native design that we know for sure. But when it comes to serverless architecture, yes, if we can file and forget, then it's absolutely the best solution. If we are trying to handle payments, it may not be. Yeah. But by the way, this is not the final answer. Right? Even in payments, we can try and use it, and then like there are ways of making it work. But we are talking about what's the most lowest hanging fruit or lowest hanging design. Yeah.
So it depends upon is stateless or statefulness.
Yes, that is I think the most important factor to keep in mind when it comes to designing applications on the cloud. If you want to make it cloud native, then I believe the only sort of applications which should be allowed to maintain states are in databases, nothing else. Anything else, any other state should be maintained in the database, the service. When I say database, I'll correct myself, it's the data store. It may be a database, it may be a caching solution, it may be Elasticsearch, the inverted indices and all these stuff, but it should be a data store which should maintain the state, and the application services should refer to the data stores to pick the state, modify it, store it back there so that everyone can access it simultaneously. Otherwise, achieving scalability is not only difficult, almost impossible. Thank you so much, everyone.
Thank you. I request you to be on the stage, and we have a small gift for you. And thanks for such a thoughtful talk. Just thank you for that. And we in Assam, especially Guwahati being now the startup hub of the Northeast, this was a very necessary topic, I think. And it was truly insightful, it had lots of facts. And as Pranav said, it's already tried and tested. So thank you so much for that. Now moving forward to our last speaker of the day, Usha and Raju, who's going to talk about artificial intelligence in autism. So, I hope everyone knows here what is an autism. So, that is, I think I'll let Usha talk about it more and have the proper conversation on that. But she is a Chief Research Officer at XR protocol, and then she's also a Google Developers expert. So if you see, she's got a couple of feathers in her hat. She's been a triple Kegel grandmaster. She's been ranked as top 10 data scientist in India for year 2020 by Analytics. India magazine ranked as top 10 women data scientists by Analytics Insight magazine for 2021. She's been AI leader and influencer by 3 AI magazines. She's also the organizer for the Neuro AI, which is first ever symposium with the interface of neuroscience and data science. And she's also organized the Neurodiversity India Summit, which is India's first conference for the neurodiversity. So today, unfortunately, we couldn't have her here physically, but she has sent her recorded video regarding how the artificial intelligence today is used for autism. So I'll just go to we try
video. So this is a deep learning for computer vision problem, basically take an MRI. Welcome to the session on AI for autism. So there's a general lack of awareness on what autism is in India. Autism is a spectrum disorder, which means people on the autism spectrum are of varying abilities. So people on the lower end of the spectrum might be completely dependent on their parents' help to walk, talk, or do their daily activities, while people on the higher end of the spectrum may completely be independent and they're just neurologically different. So this condition comes under the term, umbrella term, neurodiversity, which means these conditions are not abnormal, they're just different. They're just people who are with diverse abilities and neurologically wired differently. And today we are going to see about how AI can help people with autism. Many people on the autism spectrum are very famous, Elon Musk, Steve Jobs, Bill Gates, and all these people. And Musk recently also told he's an autistic person in a public media on last year. So some of the use cases for autism are, first use case is about the early detection of autism. So early detection of autism happens, if you can detect it before 18 months. Currently it is happening around 18 to 24 months. And if you can detect it before 18 months, that's a great success. So there's a lot of research which is happening even in Stanford University about the early detection of autism using the MRI scans of the box pictures. And if it can happen that early, then that is very great. Because the earlier you detect, you can start designing intervention programs earlier as well. So early detection is very, very, very crucial. And so this is the first use case we are dealing with. So the most commonly used mechanism here in India and in outside world for diagnosis is using the survey method, which is not very effective. So MRI scans may be a better predictor of the biomarkers for autism. So this is a deep learning for computer vision problem. Basically, you take an MRI image, do all the reprocessing, and then you apply segmentation algorithms, come up with features which you can then feed into a machine learning classifier for classification. And the biggest problem in any data science problem is the data set. The availability of data set is a huge problem. Thankfully for us, we have ABI, which is Autism Brain Imaging Data Exchange, and we have a couple of data sets from ABI which can be used as a data set for this first use case. And for the modeling part, there are several state-of-the-art algorithms for biomedical image segmentations like UNet. But the current trends are towards a transformer-based variants of UNet. One such transformer-based variant is UNET-R. There are other transformer-based variants like spin UNET-R and trans-UNet and all that. So these are some of the architectures which can be applied for modeling the first use case. The second use case is about the emotion detection in speech. Autistic people have problem identifying the tonal differences in the voice. So they cannot understand sarcasm, they cannot understand indirect speech, they have trouble identifying emotions from speech. So this is a typical emotion detection in speech problem. And for this, when we have
have an audio classification problem, you convert the audio data into Bell spectrograms. Once you convert it into a Bell spectrogram, you can apply any image classification algorithm there. So this is a typical workflow where you take an audio data, convert it into Bell spectrogram, and then apply some speech and motion detection algorithms and make a classification. The data set here is going to be MOSET, which is a corpus containing 84,000 recordings, audio recordings, and MONet is one of the recent state-of-the-art architecture for speech and motion recognition, and this is about the framework for speech and motion recognition. The next thing is about emotion detection in text. So it's again very, very difficult to identify the emotions in text for autistic people. Autistic people have trouble identifying both in speech form and in text form. Or they have trouble identifying emotions. They also have trouble identifying body language and cues, which is going to be the next use case after this. And this is just a text emotion detection pipeline where you take a text and then, if it's not labeled, we label it, then do the pre-processing, and then the deep learning pipeline comes after that. So for the data set part, we have the core emotions data set from Google, which contains a huge repository or contains a taxonomy of 27 distinct emotions. And this is an annotated data set of 58K English Reddit comments. And then we have the facial expression detection. This use case is important because autistic people have trouble identifying body language and social cues. And for the facial expression detection, it's a basic pipeline. It's like you have an input image, you do all the pre-processing, and then you have the deep learning pipeline. There are several architectures, state-of-the-art architectures already there to solve this problem. AffectNet is the data set for facial expression detection, and it contains 1 million facial images from 3 internet service providers. And then you also have distracted attention, which is one of the recent research papers which has come out. And the final use case which we are going to look about is about how to use AI to teach autistic kids the social and the behavioral skills. There's a lot of research which has come out saying robots are very good in teaching social skills for autistic people. The reason is because autistic people want certain behavior to be repeated over and over again. So maybe like for 100 times or maybe for 200 times. So any human might get exhausted, even if it's the own parent of the autistic child, they might get exhausted after 25 times. But a robot may not get exhausted and can even 1,000 times. So robots are great in teaching autistic people social and behavioral skills, and even teaching them different forms of emotions. And there are some robots outside the market. One such robot is it's a robot for assisting autistic kids, but such robots are already out there in the market and we say it costs around $5,000. We need more such robots in NGR. We need something which the audience can afford to. So I've highlighted some of the use cases of AI for autism, and we want technologists, I would encourage all technologists out here to know about these use cases and develop more products for autistic people and make the world more inclusive. Thank you.